Start by understanding what mechanical energy really means. Mechanical energy is the sum of two types of energy: kinetic energy, which is the energy of motion, and potential energy, which is stored energy due to an object's position or shape. Whenever you see a moving car, a swinging pendulum, or even a stretched rubber band, you're witnessing mechanical energy in action. This form of energy is all around us, powering everything from simple machines to complex engines. In this video, we'll explore how mechanical energy works, where it comes from, and why it's so important in our daily lives. Mechanical energy is made up of kinetic and potential energy. Kinetic energy is all about movement. Think of a rolling ball or a flying airplane. Potential energy, on the other hand, is stored up, ready to be released. Imagine a rock sitting at the edge of a cliff. It has potential energy because of its position. When it falls, that energy turns into kinetic energy. These two components work together in countless ways, making mechanical energy a key player in how things move and interact in our world. Kinetic energy is the energy of motion. Any object that's moving, whether it's a car speeding down the highway, a child running, or a thrown baseball, has kinetic energy. The faster something moves, the more kinetic energy it has. The mass of the object also matters. Heavier objects moving at the same speed have more kinetic energy than lighter ones. This concept helps explain why a fast-moving truck can do more damage than a bicycle at the same speed. Kinetic energy is everywhere, making things happen all around us. Potential energy is stored energy waiting to be used. It's like a battery that hasn't been connected yet. When you stretch a rubber band or lift a book onto a shelf, you're giving those objects potential energy. The higher or more stretched something is, the more potential energy it has. When released, this energy transforms into kinetic energy, setting things in motion. This transformation is a key part of how mechanical energy works in our everyday lives. Mechanical energy isn't just found in machines, it's everywhere in nature. Waterfalls, for example, are a perfect demonstration. Water at the top of a waterfall has potential energy because of its height. As it falls, that energy turns into kinetic energy, powering the rushing water below. Animals running, birds flying, and even the wind blowing through trees all involve mechanical energy at work. Nature constantly transforms energy from one form to another, keeping the world in motion. Machines are designed to harness and use mechanical energy efficiently. Think about a windmill. The wind's kinetic energy turns the blades, which then generate electricity or grind grain. Cars, bicycles, and even simple tools like hammers all rely on mechanical energy to function. By converting potential and kinetic energy into useful work, machines help us accomplish tasks more easily and quickly. Understanding how machines use mechanical energy can help us design better, more efficient tools. One of the most important principles in physics is the law of conservation of energy. This law states that energy cannot be created or destroyed, only transformed from one form to another. In the case of mechanical energy, this means that the total amount of kinetic and potential energy in a closed system remains constant, unless energy is added or lost to the environment. This principle helps us understand how energy moves and changes, both in nature and in machines. Mechanical energy is always on the move, changing from one form to another. When you ride a bicycle up a hill, you're using kinetic energy to gain height, which increases your potential energy. As you coast down, that potential energy turns back into kinetic energy. These transformations happen constantly, whether you're jumping, throwing a ball, or even just walking. Understanding these changes helps us see the invisible forces at play in our everyday actions. Sports are full of mechanical energy in action. When a soccer player kicks a ball, their leg's kinetic energy is transferred to the ball, sending it flying. A basketball player jumping for a dunk uses potential energy stored in their muscles, which turns into kinetic energy as they leap. Even a gymnast swinging on the bars is constantly converting energy from one form to another. These examples show how mechanical energy powers athletic performance. You might not realize it, but mechanical energy is at work all around your home. Opening a door, bouncing a ball, or even winding up a toy all involve the transfer and transformation of mechanical energy. Appliances like washing machines and fans use motors to convert electrical energy into mechanical energy, making our lives more convenient. Recognizing these everyday examples helps us appreciate the role of mechanical energy in our daily routines. Simple machines like levers, pulleys, and inclined planes are classic examples of devices that use mechanical energy. These tools make work easier by changing the direction or magnitude of a force. For example, a seesaw uses a lever to lift a person with less effort, while a pulley helps raise a heavy object by spreading the force over a longer distance. Simple machines show how mechanical energy can be harnessed in clever ways. Complex machines like cars and airplanes are made up of many simple machines working together. These machines use mechanical energy in sophisticated ways to perform tasks that would be impossible for humans alone. For instance, a car engine converts the chemical energy in fuel into mechanical energy, which then moves the wheels. Airplanes use engines and wings to generate lift and thrust, allowing them to fly. Complex machines are marvels of engineering, powered by mechanical energy. Transportation relies heavily on mechanical energy. Whether it's a train speeding down the tracks, a ship sailing across the ocean, or a bicycle cruising along a path, mechanical energy is what keeps things moving. Engines, wheels, and propellers all work by converting different forms of energy into mechanical energy, allowing us to travel faster and farther than ever before. This energy is essential for connecting people and places around the world. Construction sites are full of mechanical energy at work. Cranes lift heavy beams, bulldozers push earth, and workers use tools to build structures. All of these activities involve the transfer and use of mechanical energy. By understanding how to use this energy efficiently, construction workers can build safer, stronger, and more durable buildings. Mechanical energy is the backbone of modern construction. Entertainment devices like roller coasters, swings, and even musical instruments use mechanical energy in fun and creative ways. A roller coaster climbs to the top of a hill, building up potential energy, then races down, converting that energy into kinetic energy for a thrilling ride. Swings and musical instruments also rely on the transfer of mechanical energy to create movement and sound. These examples show how mechanical energy can be both useful and enjoyable. Nature's cycles, like the water cycle and the movement of tectonic plates, are driven by mechanical energy. Water evaporates, rises, and falls as rain, using potential and kinetic energy along the way. Earthquakes and volcanic eruptions are dramatic examples of mechanical energy being released from within the planet. These natural processes shape our world and remind us of the power of mechanical energy in the environment. Our bodies are amazing machines powered by mechanical energy. Every time you walk, run, or even blink, your muscles are converting chemical energy from food into mechanical energy. This energy allows us to move, lift objects, and perform countless tasks throughout the day. Understanding how our bodies use mechanical energy can help us stay healthy and active. Renewable energy sources like wind and hydropower use mechanical energy to generate electricity. Wind turbines capture the kinetic energy of moving air, while hydroelectric dams use the potential energy of stored water. These systems convert mechanical energy into electrical energy, providing clean power for homes and businesses. By harnessing mechanical energy from nature, we can create a more sustainable future. Factories and industrial plants rely on mechanical energy to power machines, move materials, and produce goods. Conveyor belts, assembly lines, and robotic arms all use mechanical energy to operate efficiently. By optimizing the use of this energy, industries can increase productivity and reduce waste. Mechanical energy is a driving force behind modern manufacturing. Everyday tools like scissors, wrenches, and screwdrivers use mechanical energy to help us complete tasks. When you cut paper, tighten a bolt, or drive a screw, you're applying force and using mechanical energy to get the job done. These simple tools make our lives easier by allowing us to use energy more effectively. Toys like wind-up cars, spinning tops, and bouncing balls are great examples of mechanical energy in action. When you wind up a toy or pull it back, you're storing potential energy. As the toy moves, that energy turns into kinetic energy, creating fun and movement. These playful examples help us see how mechanical energy works in simple, hands-on ways. Musical instruments like drums, guitars, and pianos use mechanical energy to create sound. Striking a drum, plucking a guitar string, or pressing a piano key all involve the transfer of energy from your hands to the instrument. The vibrations produced by these actions generate sound waves, filling the air with music. Mechanical energy brings music to life. Artists use mechanical energy when they paint, sculpt, or draw. Every brushstroke, chisel tap, or pencil line involves the movement of hands and tools, transferring energy to create beautiful works of art. Even kinetic sculptures, which move on their own, are powered by mechanical energy. Art and energy are more connected than you might think. Farmers use mechanical energy to plant, harvest, and process crops. Tractors, plows, and harvesters are all machines that convert fuel into mechanical energy, making farming more efficient. Even simple tools like shovels and hoes rely on human muscle power to get the job done. Mechanical energy is essential for feeding the world. Scientists use mechanical energy in experiments and research. From launching rockets to studying earthquakes, understanding how energy moves and changes is key to scientific discovery. Laboratory equipment like centrifuges and shakers use mechanical energy to mix, spin, or separate materials. Science relies on mechanical energy to unlock the secrets of the universe. Medical devices like wheelchairs, prosthetics, and surgical tools use mechanical energy to help patients and doctors. These devices convert energy into movement, making it possible to perform delicate procedures or assist with mobility. Mechanical energy plays a vital role in improving health and saving lives. Communication devices like telegraphs, typewriters, and even early telephones used mechanical energy to send messages. Pressing keys, turning dials, or ringing bells all involved the transfer of energy. While modern devices rely more on electricity, the roots of communication technology are grounded in mechanical energy. Throughout history, mechanical energy has powered inventions that changed the world. The wheel, the lever, and the steam engine are just a few examples of how humans have harnessed mechanical energy to build civilizations, travel, and create new technologies. Understanding the history of mechanical energy helps us appreciate its impact on society. Using mechanical energy safely is important in all areas of life. Machines and tools must be designed and operated with care to prevent accidents. Safety features like guards, brakes, and warning signs help protect people from harm. Understanding how mechanical energy works can help us use it responsibly and avoid danger. Mechanical energy can have both positive and negative effects on the environment. Machines help us build and travel, but they can also cause pollution and use up resources. By designing more efficient machines and using renewable energy sources, we can reduce the impact of mechanical energy on the planet and create a more sustainable future. Innovation in mechanical energy has led to amazing advancements, from electric cars to high-speed trains. Engineers and inventors are constantly finding new ways to use mechanical energy more efficiently and creatively. These innovations are shaping the future of transportation, industry, and daily life. Learning about mechanical energy is an important part of science education. Experiments with pendulums, ramps, and springs help students see energy in action. By exploring these concepts hands-on, learners gain a deeper understanding of how the world works and how energy powers everything around us. Space exploration relies on mechanical energy to launch rockets, move satellites, and operate rovers on distant planets. The engines that power spacecraft convert chemical energy into mechanical energy, propelling them beyond Earth's atmosphere. Mechanical energy is key to exploring the universe and expanding our knowledge of space. Water wheels, turbines, and pumps use the mechanical energy of moving water to perform work. These devices have been used for centuries to grind grain, generate electricity, and move water for irrigation. Harnessing the power of water's motion is a classic example of mechanical energy in action. Windmills and turbines capture the mechanical energy of moving air to grind grain or generate electricity. Even sailing ships use the wind's kinetic energy to travel across oceans. By understanding and using the mechanical energy in air, we can create clean power and efficient transportation. Fire can be used to create mechanical energy by heating water to produce steam. Steam engines were a major breakthrough in history, powering trains, ships, and factories. The conversion of heat energy into mechanical energy changed the world and sparked the Industrial Revolution. When we eat, our bodies convert the chemical energy in food into mechanical energy for movement and activity. This process powers everything we do, from walking and talking to playing sports. Food is the fuel that keeps our internal engines running. Animals use mechanical energy to move, hunt, and survive. Birds fly, fish swim, and cheetahs run at incredible speeds, all thanks to the conversion of stored energy into motion. Observing animals in action is a great way to see mechanical energy at work in the natural world. Plants use mechanical energy in subtle ways. For example, some plants can move their leaves or flowers to follow the sun, a process called heliotropism. Others use stored energy to release seeds or close their leaves at night. These movements, though slow, are fascinating examples of mechanical energy in the plant kingdom. Weather events like wind, rain, and storms are powered by mechanical energy. Wind moves clouds and shapes landscapes, while falling rain and flowing rivers transfer energy across the earth. Understanding the role of mechanical energy in weather helps meteorologists predict and explain natural phenomena. Board games, pinball machines, and playground equipment all use mechanical energy to create fun and excitement. Rolling dice, spinning wheels, and swinging on a slide are all examples of energy being transferred and transformed. Games are a playful way to explore the principles of mechanical energy. Some art installations use moving parts powered by mechanical energy to create dynamic displays. Kinetic art pieces spin, sway, or move in response to wind or touch, captivating viewers with their motion. These installations blend creativity and engineering, showing the artistic side of mechanical energy. Robots use mechanical energy to move, lift, and interact with their environment. Motors and gears convert electrical energy into mechanical energy, allowing robots to perform complex tasks. Robotics is a rapidly growing field that relies on a deep understanding of mechanical energy and its applications. The future of mechanical energy is full of possibilities. From renewable energy sources to advanced robotics and transportation, new technologies are constantly emerging. By continuing to study and innovate, we can use mechanical energy to solve problems and improve life for everyone. Mechanical energy is a fundamental force that shapes our world. From the smallest toys to the largest machines, from nature to technology, it powers movement, work, and creativity. By understanding how mechanical energy works and how it can be used responsibly, we can build a better, more efficient, and sustainable future. Thanks for joining us on this journey through the world of mechanical energy.